Hello! In this video, we're going to learn about Pandas. Pandas is a Python module that's built around data frames. Data frames are a very convenient data type for doing statistics and data science. We're going to learn how to read in data frames using Panda, how to quickly assess data frame properties, how to select columns of a data frame, how to perform descriptive statistics using Pandas, how to mask data, how to use .iloc to isolate data within a data frame, and how to plot with Seaborn. So let's get started. The first thing to do is to import Pandas. And Pandas is usually imported as PD. And to make Pandas useful, we usually read in data. So this is the first time that we're going to read in data into Python, and you create a variable to store your data. And we're going to be using CSV files. So the Pandas function is read CSV. And if you load into your home directory from where you're running Jupyter Notebook, the data file, you should be able to directly access it. But otherwise, you would specify the path to wherever the file was. The data that we're going to be looking at today is called CO2 MLO weekly.csv. This is weekly CO2 concentrations that have been taken in Hawaii for the past 3 or so years. So if you have a data frame and data ready to go, for example, it's a CSV file, you just use read CSV with Pandas and you store it in a variable. Once you have your data frame, you can very quickly try to look at it and figure out what it is. You should think of a data frame just like an Excel sheet. It has rows and it has columns, but it's convenient to know what those columns and rows look like and just to make sure that your data was read in correctly. So you refer to a data frame, and then to use a particular function, you do dot and you write the function that is in Pandas. And so a common function is called head. And what this will do is it will read in the first lines of your data, and you can see that there are columns, and you should make sure that it aligns well with your data. And you have these rows. And because we're working with Pandas, which is meant for data analysis like we're doing, you can see how nicely it's formatted with these alternating shadings, and the columns and the header are formatted very nicely as well. You should notice that the rows, as we're in Python, start with 0 and go onwards, but that the header is separate from that. And these are formal column names, and then your rows of data start with 0 going down. So let's look at some of these more of these functions that allow us to look at our data. Just like you have head, you have tail as well. So you can use the tail function to look at the very last lines of your data. This is convenient sometimes to know how many lines of data you have. For example, we have 713 entries. Our columns here are the date. We have a running date, which is each of the entries just marked with a day. Remember, this starts with a 0, so this is 1 further than that. This is just a categorical variable of which month we were in. This is the year, and this is the CO2 concentration in parts per million. Beyond just looking at the head and the tail of the data, there's also a function describe that is very useful. And so we do .describe, shift enter. And what this will do is for any column that has a continuous variable, that is a number-based variable, it will show you a lot of convenient summary statistics like the count, how many of things, the mean, standard deviation, minimums, quantiles at the 25, 50, and 75% values, and max. And so you can see that we're going from years 2017 to 2019. We have CO2 levels from 402 to 415. The mean is about 408, and then you have a running date too, going from 1 to 714. So that's a little bit about how to know your data. Sometimes you have to convert between a continuous and a categorical variable, and it's important to keep track of which of your variables are continuous and categorical. So when we do a tail and head, we can see all of our columns, regardless if they're qualitative or quantitative, categorical or continuous. But when we do describe, you can see that we're only doing statistics on the things that have numbers. We can't run statistics on month, for example. But sometimes maybe you want to turn a continuous variable like year into a categorical variable because we only have 2017, 2018, and 2019. So maybe it's easier just to refer to year as a categorical variable. To do that, let's learn how we select a specific column in a Pandas data frame. And this is very easy. You use square brackets and you refer to the column name. So we want to alter the column year. So we refer to the data frame, data, and we use square brackets and we say year. And then we can say that we're going to set data year. We're going to take the values in data year itself, and then we're going to use a function called as type, and then we can say we want it to be a string. So here we've learned how to select a column in Pandas data frames. You just use square brackets, refer to the column name as a string, and what we're going to do is we're going to use this function as type to convert year into a string and reset this column to a string value instead of being a number. And so now, if we do data.describe, what you'll see is that there's no more year, where once we had year, we don't, because now it's a categorical variable. So we can't do all these statistics. And the only ones we can do statistics on are running date and CO2 parts per a million. So that's a bit about how you select columns. And once we have this ability to select columns, you can do all sorts of really handy built-in statistics with Pandas. So let's say for all the CO2 values, so to do that, we select the CO2 column, square brackets and name. We just want the minimum value. What was the lowest CO2 value in the span of 2017 to 2019? And it was 402. We can do the same thing, and we can look at the max value. The CO2 values are going to go up to 415. We can take a mean and just refer to mean. And there we get 408. And we can also do a median. And there we go. There's our median value. There's a lot of functions that further help you to understand what your data looks like, especially for categorical variables. For example, maybe we wanted to know all the different levels of the categorical variable. Levels of the categorical variable are all the different types. So to look at that, we look at our categorical variable month, and the function is unique, which is how many unique levels are there. And you can see we get each of the months when we look at all the different levels of month. Maybe we want to know how many of each of the different levels of a categorical variable that there are. And so to do that, we select our column, and then we use the function value counts. And there you go. You can see how many values we have for each of the different months. Pandas even has plotting functions built in. Something we always want to know when we're doing statistics is what is the distribution of the data that we're looking at. And to do that, the function is just .hist for histogram. So if we want to look at histogram of our CO2 values, it's not working here. Sometimes it takes a little bit to run. Oh, there we go. And there we go. We have a histogram of our different CO2 values. So that's how you can do select columns, how you can do summary statistics on the values of just a column. And you can even do summary statistics of very basic plotting, of looking at histograms using Pandas. Now, what if we wanted to isolate specific data? And the way that we primarily do that is called a mask. And a mask is simply a Boolean statement. That's all you have to remember. So you can just say mask equals, And then you create a Boolean statement of the data that you would like to look at. So let's go to, let's just say for some reason that we wanted just the August values. And so the way we would do that is we just say mask equals, and then mask is equal to this Boolean statement. And so what this is going to do is it's going to fish out all the rows in which this statement is true, in which it is true that a row for the month column equals August. And so if you just look at what a mask was, if you remember at the very beginning of our data set were the August values, and so these rows are true because month is equal to August, but the other rows are false because they're not equal to August. So what you need to remember about mask is, what do you want? And so you create a Boolean statement for what you want. The mask is equal to that Boolean statement of whatever it is that you want. And so once you've created your mask, you have this list, this series of true and false values. If you put in the square brackets, what it's going to do is it's going to select those rows that are true. So we created our mask up here. We wanted all those rows where it was true that the month equals August. That Boolean statement is our mask. We can put that mask into the square brackets of our data frame, and what we get back is only the true columns. So we have fished out of our data set only those values where it was true that that month equals August. Maybe you don't want all the columns. Maybe you just want, for example, the CO2 values from August. And so to do that, you select a column. In this case, we're going to select CO2. And then you just put as a second bracket the mask. And so this is kind of, it's the same thing, just where we had data frame and then mask, except we're saying it's not the whole data frame, it's just the CO2 column. And we're going to use the mask again. And then what we get back is just those CO2 values only that come from August. And so let's put this all together. What we've done is we've broken down how you'll actually usually see a mask in code. And what a mask looks like in real life is actually really complicated. But we just did it piecemeal. So we would first select the data that we'd want, which is the CO2 data. And then in the second brackets, we're putting mask. But the mask is, we don't usually refer to it as a variable mask. We usually write out the whole thing. So our mask was for where month equaled August. So let's break this down a little bit. It's a lot of verbiage, but we have here the data that we ultimately want, which is we only want the CO2 values. And then the second part was where up above we had put mask. But instead of putting mask, we just put the actual mask itself. And remember, a mask is just a Boolean statement of what you want. So we want only data where in the column month it equals August. And then we're just going to return only those CO2 values. And so there we go. This is the complicated way that usually we write our masks. Masks are very useful for isolating specific types of data. Just remember it's a Boolean statement in square brackets next to whatever column or data frame you'd like to look at. So that's how to make a mask. Let's reorient ourselves and look at what this data looks like again. Masks are one way to fish out data, but another way is much more numerical. It's called .iloc. And what you have to remember about .iloc is that it is rows followed by columns. It's a lot like Battleship, where you're first saying which row something is in and which column it is in. Remember, our rows are 0 onwards, and our columns too are 0 going onwards. So because it's row column, if you just put a single number into the iloc function, which is integer location system, and let's say we just put 0. Because it is row column, we've essentially just put a row. And what we're going to get back if we put in 0 is the first row. We can also use a negative system too. So you can say -1, and that would return the last row. But because we only put a single number, and this works as row followed by column, the first number refers to row. The more formal way to do this, if you wanted to look at rows too, was, let's just say we want the last row, but you could also formally say comma, which gets you to the columns, and then a colon. And the colon is there because the way it is that this is indexing from start to end, but by just putting a colon, it's kind of like a placeholder that says all columns. So we have rows, comma, columns, and we're saying all the columns with a colon. And so we get the exact same thing because we're looking at the last row for all the different columns. If you want a column, you can't just put a number. You actually have to go through this notation where you use colon for all the rows from start to end, let's say for the first column. So what we have retrieved here is now the first column, the 0th column. And you can do this for other columns as well. You could do it for the first column. And there you go. We have the first column, which is the running date. You can do both rows and column selection as well. So we put our data frame, we put the function iloc, and then let's say we wanted something complicated, like rows 2 through 4 for columns 2 onwards to the end. So we get our rows 2 through 3, because remember with the indexing, we go up to but not including the end. So we get rows 2 and 3 back for here. So this is rows start to end. And remember the end, it's really complicated. It's up to but not including. Then after the comma, we have our columns, and we selected column 2, but onward. So it includes 3 and 4 as well. You can do much more complicated notations too. You can do data frame, function iloc, put in your square brackets, but then you can put square brackets in for rows. Let's say we wanted not continuous rows. Let's say we want rows 0, 3, 5, and 7. And then for our columns, let's say we want columns 0, 2, and 4. And there we go. So with brackets within brackets for rows and columns, you can retrieve whatever different rows you want, as well as whatever different columns you want. So let's just review that just a little bit, the iloc notation. It's very useful for locating data. Just one number, it's a row. You can use negatives to get the last row as well. But if it's two numbers separated by a comma, it's rows, columns. And if you just put in a colon, you get all the things back, whether it's the columns or the rows. And if you want columns, then you formally have to put all the rows, comma, and the column that you want. You can do more complicated things too. You can do start and end, and remember it goes up to but not including the end. If you put nothing on one side, it means everything up to the end, or you could have put nothing on the other side and it's everything up to the beginning. And then you can also just not do continuous selection of rows and columns, and just whatever you want in two sets of square brackets for rows and columns. So that's about the .iloc function and how to isolate data. And now let's do some plotting. So before, we have been using matplotlib and pyplot. And remember, we always do our inline. But now let's look at something called Seaborn. Seaborn is a package that will do a lot more statistical graphing. It's not as flexible as matplotlib, but in many ways, if you're doing a specific visualization of statistics, it is usually much more elegant and easy to use. And I misspelled matplotlib. There we go. So we imported matplotlib. And we usually import Seaborn as SNS. Seaborn has a lot of different styles, and I highly encourage you to look up the documentation for Seaborn. Actually, the best way to use Seaborn is to look at the gallery of the documentation. They have a gallery of all the different beautiful graphs that you can make with Seaborn. I would look at that gallery, try to see what you want, click on the graphic, and the documentation is usually really good to tell you about how to use Seaborn. One of the elements of Seaborn is that it has styles. And if you just say seaborn.set parentheses, it will set a really elegant style for you. But there's a lot of other different styles, and you should take a look at those too in the documentation. You can even use Seaborn in a way to set a style for figures or a presentation or for a poster, and it will automatically change the font sizes and the aspect ratios and everything of your graph to make it useful for those different purposes. So please look at the documentation, the gallery for Seaborn, look at all the different graphs and find what you need, and look at the styles as well. So let's make a graph. Seaborn is great because it works so well with a data frame. The first type of the most useful plot usually you'll find is a LM plot. It stands for linear modeling. But as you'll see, you can also use this as a scatter plot. But you can refer to the X and Y variables just using the column names. And so you can say X is going to be our running date for the CO2. Our Y is going to be the CO2 in parts per a million. But having done all this, just referring to the column names, you do have to say what your data frame is. So our data frame is called data. So if we do this graph, you can see we get this very elegant graph. We can see our data. CO2 levels fluctuate across the year, and that's what you're looking at from 2017 through 2019. And this is an LM plot for linear model. You can see that it fits a really nice line, a linear model through your data. This is useful if you're looking at correlation or actually doing linear modeling. Sometimes, though, you just want a scatter plot. You don't want the actual line in there. And so one of the arguments is called fitreg, reg. And you can just set that equal to false. And when you do that, you can get rid of the line and essentially just have a scatter plot. Again, look at the gallery. There's so many different things you can do, but let's just do a histogram. In Seaborn, a histogram is called a distance plot. And here you can just refer to the column that you want to plot. And there you go. You have this beautiful histogram, but it also fits a continuous probability distribution for your histogram as well. It's really elegant. You can do a lot of the same tricks that we use with matplotlib. Remember with matplotlib that if we want to look at, if we want to separate our data in one plot, we kind of keep on making multiple plots. You can do the same thing with Seaborn. Let's do this. Let's create 3 masks for only the data from 2017, 2018, and 2019. So if we want a mask, we say we're going to call the first mask year 2017, just the 2017 data. It will be the CO2 parts per million that we're after. And the mask will be where data, year, and our Boolean statement is where Boolean year equals 2017. And remember, we're creating a string because we actually purposely made our year into a string. And so let's do this for 2018 and 2019 as well. All we do is we just copy and paste and change the numbers. And there we go. We should have our 3 masked data sets of all 2017, 2018, and 2019 data. Then we just make our Seaborn distance plot using year 2017. And remember, just like in Matplotlib, we give labels. And this is, we'll call that 2017. And we're going to do 2 more of these. for 2018 and 2019. And there we go. And just like matplotlib2, in fact, using pyplot, we call up the legend function. And so this is like making 3 plots simultaneously. We keep our labels, we have a legend, and then Seaborn will make this beautiful plot. So again, Seaborn is very useful for Pandas, and Pandas and Seaborns are both built with statistics and data analysis in mind. And they both revolve around a data frame, which is a very convenient data type for statistics. So let's very quickly look at what we learned today. We learned how to read in data frames using Pandas, using head and tail and describe. We can quickly look at the properties of a data frame and get a feeling for it. Using square brackets and quotes, we can refer to column names and retrieve just and select a particular column. Once we select particular columns, we can use dot functions of dot min, max, mean, median, standard deviation, unique values, value counts, to look at descriptive statistics and know about categorical variables better. We learned how to mask data. Remember that a mask is nothing but a Boolean statement. It is a Boolean statement to fish out the data that you want. This mask can be used with square brackets after a particular column or data frame, and it will give you back the data that you wanted that fits the Boolean statement. We learned how to use the .iloc function. Remember about .iloc that it's rows first, columns second, separated by a comma. You can select rows and columns to start and end by using a colon, and you can be much more specific using square brackets within the square brackets for each rows and columns. And then we learned how to plot with Seaborn. Seaborn is a very specialized plotting module in Python, and it's used for very specific statistical functions, and it can create very elegant functions if it does what you want, what you need it to do. And you should be looking at the gallery and documentation of Seaborn to know the different plots that it can make. So that's all for this video. Thanks for watching.